Hello everyone and welcome to 30 Days of Java. It's day 12 now and today we'll continue our discussion about classes and objects in Java. Our agenda for this video would be to understand what is a method and constructor in Java. Then we'll talk about access modifier and how they implement the concept of encapsulation in Java. So let's begin. A method or function is a block of code that performs a specific task or action. Methods are used to break down programs into smaller, more manageable pieces, making the code more organized, reusable, and easier to understand. A method structure starts with how accessible it is, defined by access modifier, then what it gives back, defined by return type, and finally its name along with any input it needs, defined by parameters enclosed in parentheses if there are any. Let's see all of this in action in IntelliJ. Let's first understand why do we need methods in the first place. Suppose if we are creating a program in which we have to perform all the arithmetic operations on two numbers, then we'll start by typing double a equal to 10, comma b equal to 20. Then we'll output the values as addition a plus b then comes subtraction, then multiplication, then division and modulo as well. Now this program looks clean for now. Suppose if I want to repeat this process again for another two numbers, let's just say we change the value of a and b to 100 and b to 200. Now again we want to do the same process for another two numbers. Say 99 and let's just say 90. The main problem with this approach is that it's making the code more and more messy and unclear to read. If we keep following this approach, we are doomed to make a mistake. So one way to clear up this code is by using a user-defined method. So what we'll do is we'll create a method here. First comes the access modifier, public, then the return type, which is void, and then the name of the method, that is calculate. Since we need two values for it, we'll pass in double a, double b. These are the arguments that the method would work on. Then we'll just use this code in the user-defined method. And instead of typing that same code again and again in the main method, we'll simply call the calculate method. Also, we'll need to make this a static method, since we also don't want to instantiate the object before using it. So now we can just write calculate a, comma b. We can copy paste this again for line number 10 to 14 and again for line number 15. Now this code looks way more cleaner and easier to read than the code before. If I run this program, the output would be the same as before. The two main reasons of using method are: first, it makes the code more readable and clean, as you can see in this example, and second, it makes the debugging way more easier. Suppose if I make any mistake while creating this method, and if I change this value as addition to additions, now if I run this program, I see that in the output there is additions, there is an extra s here. So I can simply go to that particular method here, calculate, and see what is the issue here. If I was using this line of code in the main function, I had to check all the lines of code in main function one by one till I found the error. But using methods make the program more modular, which is more easier to debug. A constructor in Java is like a special method that gets called automatically when you create an object from a class. Its main job is to initialize the object by setting up its initial state or values. Think of it as the blueprint that prepares a house before you move in. It sets up everything just the way you want it when the house is first built. In Java, a constructor has the same name as the class it belongs to, and it doesn't have a return type. Constructors in Java can be divided into two categories: default constructor and parameterized constructor. Default constructor, as the name suggests, is created automatically by the compiler, even if you don't define it in your code. Whereas the parameterized constructor needs to be explicitly defined in code. Another difference between the two is default constructor doesn't take any arguments, whereas the parameterized constructor does. Access modifiers in Java are keywords that specify the accessibility or visibility of classes, variables, methods, and constructors. There are four types of access modifier in Java: public, protected, private, and default. Let's take a simple example to better understand this concept. In your daily life, the public modifier is like the information you're comfortable sharing with everyone, like your favorite food or hobby. The protected modifier is more like a secret you only share with your close friends or family, things you trust them to keep to themselves. And the private modifier? Well, that's reserved for your deepest, most personal secrets, stuff you only keep to yourself because it's just for you. The default modifier can be considered as things that you don't really tell outsiders, but it's not really a secret, like your age or birthday. Encapsulation in Java is like putting things in a box and only allowing certain ways to interact with them. Imagine you have a box with a lock. You can't directly access what's inside the box, but you can use the key, that is, methods, to open and interact with it. In Java, encapsulation means wrapping up data and methods together in a class and controlling access to them using access modifiers like public, private, and protected. This helps to organize and protect your code, making it easier to manage and preventing unwanted changes from outside the box. Let's now see all of this in action in IntelliJ. For understanding the concept of access modifiers in Java, we'll need to create another class in our project. So we'll go to src folder, then right click on it, new, and then Java class. We'll name this class as bank account. Now this class would represent a really simple bank, which would have the properties name, public, int, amount. That is the amount of money that your account has. Let's give it a value of 10,000. Now this class also would have method name, public void show amount. This method would output the amount of money that your account have. So test out, and then your total balance is amount. Now suppose if I make an object of this class in my main function, say bank account equal to new bank account, and I enter account dot show amount. Now if I run this program, this would output me the current balance of my account, that is 10,000. Now suppose if a hacker or a bad programmer gets access to the current amount of money that your account has, he can accidentally or intentionally write account.amount equal to 0. Now if I run this program, your total balance is 0. All your saving just became 0. Now this is a really serious problem, as it can significantly impact the production. To tackle this problem or rectify this, we have different access modifiers. Right now, the access modifier that the amount property has is public. That is why we can access it outside the class. But if I change this access modifier from public to say private, and then go to my program main, you can see that it's showing me the amount in red highlighted. It's saying amount has private access in bank account. That is why it can't be used outside the class. If I run this program, it would throw a compile time error. Now I can't make the changes in the balance of the account from outside the class. Now suppose if I want to credit or debit some money into the account, then how do I do that? So we can do one thing. We can create another method under bank account and name it public void credit or debit. This would take in an argument named amount to be credited or debited. Now we can change the amount by typing in amount plus equal to amount to be credited or debited. And for security purposes, we can also pass in a pin. We'll type in int pin if pin equal to 1 to 3, which let's just say is the pin for this account, then only it is able to make the changes in the amount. Otherwise, it would simply say access denied. Now if I try to make any changes in the amount by typing in account dot credit or debit and then pass in the value, let's just say 800, and pin as 1 to 3, and also type in account dot show amount, and then run this program. You can see it made the changes in the amount, that is 10,800 now. If I give it a different pin, Let's just say I give it 124 and then run this program. It would simply say access denied. Now that is a really basic example of how access modifier works. For now, we have seen how public and private access modifier works. For default or protected, we'll need to cover some more topics like inheritance to fully understand them. We'll talk about them when we discuss about inheritance. Before ending this video, I'll also talk about constructor. A constructor is a special method that is called when an object is created. For now, you can't see that it's being called, but it is. We're calling it when using this new bank account. This is invoking the default constructor that is automatically created by the Java compiler. Suppose if we create our own user-defined constructor, we'll just type in public bank account. And then let's just say constructor was called. Now this is a default constructor that we just created ourselves. So now if I run this program again, you can see the first line is constructor was called. That was shown when line number 4 was executed, which invoked our user-defined default constructor. Another thing to note is that whenever you are creating a user-defined constructor, it would always overwrite the default constructor that the Java compiler writes. That is, your user-defined default constructor would be used. So why do we need constructor in the first place? Well, in this scenario where we are creating the bank account, we have already given it the amount of 10,000 as the starting sum, but not all bank accounts would have that sum as the initial amount. So what we can do is we can create a parameterized constructor here saying int amount and then type in this amount equal to amount. Now when we are making the object of this class, we'll just type in, let's just say 20,000. That is the starting amount for this new account. Now if I run this program again, it initializes the value to 20,000. You can use the constructor to initialize the values of new objects when they are created. As always, we'll end this video with a motivation quote that says, "It is during our darkest moments that we must focus to see the light." Thank you for watching and have a great day.